we want to rewrite this limit and sum in terms of integrals. So there's going to be three different approaches that we're going to take. So the first one, we want to compare this to the definition of an integral. So if you have the integral from a to b, f of x dx, we know that it's a limit of the sum, delta x times f of x k star. Here delta x is b minus a over n, and this is some point x k star in the interval. Okay, so now we're going to compare the definition of the integral with what sum we're given. And clearly we see that delta x has to be b minus a over n. So that's the 8 over n. So here the length of the interval is 8 because b minus a is 8. And in order to get the function, you need to remove delta x. So for us, delta x, we said, is 8 over n. So over here, just remove 8 over n to get your function. It would be negative 2 plus k cubed, or if you think of it as f of x, negative 2 plus x cubed. And this method assumes that you start at 0. So a is always going to be 0 with this method. Another method I'm going to talk about is going to be it's going to start somewhere else. So the integral starts at 0 always, and then we know that the length of the interval is 8, so it has to go from 0 to 8. The function we just said is negative 2 plus x cubed dx. So that is our integral. Now we're going to use the same approach, except just play around with it and use some algebra. Okay, so this 8 over here, actually this 8 and k over here is going to get broken up and it's going to be put in front. And then this 8 is going to come in front over here. Okay, so this is going to change what my function is. We'll talk about that in a second. But here, delta x is going to be 1 over n. Okay, so that's 1 over n, 1 over n. These are delta x's. And b minus a over n is 1 over n. That means b minus a is 1. So the length of the interval is going to be 1. Again, this approach assumes a is 0. Okay, in order to get the function, you need to remove delta x. Delta x is this. And obviously you ignore this because, like we said, this is our f of x. F of x k star, whatever. Okay, so remove that and you could just read it off, what f of x is. So here I just said f of k since it depends on k. So f of k is 8 times the quantity negative 2 plus 8k cubed. So putting it all together, we said that this starts at 0. The length of the interval is 1. So this should be 1 actually. And then we have the function 8 times negative 2 plus 8x cubed dx. Now let's look at a different approach. So this approach says that the inside function is a plus delta xk. So this entire thing is going to be a plus delta xk. A clearly has to be negative 2. Okay, delta x is 8 over n. Okay, so you're multiplying it by k, delta xk. Here's k. The rest is your delta x. And it's also all here. So now you get your function. Your function is going to be x cubed. So the way to think about it is whatever you plug in. So this is whatever you plugged in, right? A plus delta x is this entire inside. Whatever you plugged in, you're going to cube it. So your function is x cubed. Okay, this starts at negative 2. So a is negative 2. We know the length of the interval is 8, since 8 over n is your delta x. And so that is b minus a over n. That means 8 is b minus a. And then a we said is negative 2. So that's b minus negative 2 is b plus 2. So then b has to be 6. Okay. And so this approach gives us the integral negative 2 to 6 of x cubed dx.